All right, last time we started talking about how to link tables together. First thing we did, just as a quick review, is added a new record for me into the database, primarily because this person does not have any trips in the database. And we discovered later on when we joined the tables together, whenever you join tables together, you only get records for people or for employees where the two tables match. Obviously, if I say give me the list of all the trips for people who work in plant one, I'm not going to get trips for the other plants. But you're also not going to get trips for people who do work in plant one who don't have any corresponding trips. So when you link tables together, you only get the records that match in those tables that are linked. So we'll see that here again in a second. The best way to join tables is with the using clause. In any case, we're going to use join. Inner is optional. Whether you type it or not is up to you. I like to type it just to help me remember that this is an inner versus an outer join that we'll learn about today. You can mix and match fields from any table as long as you designate how to join those tables together. And this is where the ERDs can come in very handy. In our in-class examples, there's only three tables really: plants, employees, and trips, and how those are related. We had them up on the board, pretty easy to keep straight. But when you get into Henry Books and Premier Products, 7, 8 some odd tables, it's definitely an advantage to have those tables, the ERD in another window or printed out next to you so that to help you until you get very comfortable with them, help you link the tables together. So we can use any fields that we want up here. And then you list the tables that are involved. Again, in my notes, it talks briefly about how to link tables using a where clause. I'm going to ask you not to do that. I have modified, I hope it's posted, this Unit 2 or the multi-table queries assignment to say don't use where to join tables. Unless, hi. Matt, you want to, while I'm reviewing, talk to Patrick? Thank you. Don't use where unless the book says so. All right. So I'm joining tables here using the join command. That to me is the better way to join tables. It shows that we're doing this for relationship purposes, not for filtering purposes. Where works. You'll see lots of examples on the web where works. But I think the better way, the more logical way to join tables is using the join clause. And you provide a join command for each table beyond one. So here I'm saying give me everything from the employees table. But I also need the trips table, so join the employees table to the trips table using this common field. That common field needs to be in both tables. That should be your foreign key and your primary key in the two tables. If the names are the same, you can use a using command, which makes this much easier to type. Here's the alternative version that's a little more complicated. It's not terrible, but this is quicker and more convenient. And what's also convenient is if there is an employee ID, if you want to display it for some goofy reason, which is rare, if you want to display it, you don't have to qualify it. The employee ID is listed in both the employees table and the trips table. And normally you have to qualify fields if they're in both. If you use the using clause, the SQL command knows, or the SQL compiler or somebody knows, that doesn't matter which employee ID because they're always going to match. So it doesn't matter if I get it from the trip table or if I get it from the employees table, they will match. And so you don't have to qualify it using this technique. It really is not a big deal because normally I don't show auto number fields in my select clauses anyways. And that's really where most tables overlap. So, using. We can take that to multiple levels. Here's another example down here. Here's the other way to join tables. Select these fields from plants. Inner join. All that's the same, except notice I've given an alias to the plants table. That's to make this part over here a little easier. I've given an alias to the employees table. Aliases do not have to be one letter. I'm just trying to make things a little easy on myself here, so I make a one-letter alias that's only available for this select command. And then instead of a using clause, you use an on clause. And you designate which field from table 1 is related to which field in table 2. If for some reason the two field names, the logic or the foreign key and the primary key, if they don't have the same name, you must use this technique. It's the only way to join them. If you have a table that's joined to itself, think our employees and supervisors tables. In your database design one, or where was, no, I think that was the build one, where the employees table is linked to itself. Supervisors have multiple employees. Who's my supervisor? The supervisor ID field obviously has a different name than the employee ID field, but that's how we link them. Who's my supervisor? The employee who has this supervisor ID. You have to use this technique to link that table to itself, because the two fields have different names. Once you've linked tables together, you can use any fields in the field list that you want from those two tables. You can use any fields that you want in the where clause. Destination is in the trips table, even though it's in the middle here. You can use any fields you want in the order by clause. So you can mix and match them. Once these tables are joined, I picture them as this big, huge monster table with a bunch of fields. And you can use any of the fields in calculations, any of the fields in the where clause, any of the fields in the order by clause. So here's an example where I'm doing calculations. In this case, both the first and the last name come from the employees table. That doesn't have to be the case. If we were calculating GPA, your grade was stored in one table, and the point or the credits that's necessary is stored in another table. You can put those two together in one formula as long as you join the tables. So calculations, where clauses, I don't have an order by here. I could easily add an order by clause. And notice the multiple joins. Here I'm being a little more consistent using the inner. It's not necessarily required to use the inner. I think it just helps with clarity a little bit. And you can do multiple usings. Somehow magically it figures out that this plant ID is shared with the employees table. SQL sorts all that out. The order of these joins doesn't seem to make too much difference here. For the purposes of this class, probably won't need to worry about it too much. But real world, in the Alliance camp, we're finding in a couple places that the order of the joins makes a difference because there may be more than one path. There may be more than one relationship between two tables. I think about that. Which one was it? It was the volunteers who fill positions with their skills table. They kind of had this circular connection. There are multiple ways to get to relate tables there. Sometimes you need to relate them in the right ways. Most of the time, in an inner join, the order doesn't matter. I tend to go from parent to child, but that's just my technique. So there's the review. Any questions? Yes, sir.
Kind of a little, it's not necessarily exactly on this. When you're building your database,
yes,
and you use your auto assign numbers,
mm-hmm.
When you're building your next table, how does it connect to that auto number?
You have to enter it somehow. Okay, so if I go into my employees list here,
so you do have to know the number then to connect them together.
Yes and no. So his question is, how do we know which numbers to put in here? If you're typing the data manually using an insert command, or you're in Access and there's something, then you have to know that number. What you'll learn in Programming Logic Intermediate is, who knows those numbers? Volker says we don't want them to know those numbers, right? Why is Coloma plant number 1? There's no reason. It just is. With 4 plants, we can kind of keep them straight. But with 5,000, 10,000 students, it's hard for me to remember what your student ID number is. Right? What you'll learn in Programming Logic Unit 4, so when we come back from break, what you'll learn in Programming Logic Unit 4 is how to build a combo box that shows the plant names, Coloma, Saugatuck, Polonia. And behind the scenes in the combo box, we store the ID number. So the user picks it by name, which is the human natural way to say, here's the plant that I belong to. And behind the scenes, our GUI is going to send the number 2, or whatever it would be, to the business class that said, this guy works in plant number 2. And the business class doesn't even store the name, never does. And so using GUIs, we can hide this information. We can create forms and access that do exactly the same thing. In my intermediate access class, the first unit talks about how to create lookups so that we look up a plant and not force you, the human, to go find out what the plant ID is. For right now, when you're doing your insert commands in the build and populate, for instance, when you're doing your insert commands, you have to insert these numbers. Poor database administrators have to go find those numbers. Maybe it's in another screen someplace. They find the numbers that they look for and they type them in if they're typing in data. Data is rarely entered by humans into a database table directly. It's very, very rare because we have no validation that way, right? Most data is entered using some kind of a form. Reen and all his buddies are spending more time doing validation, just like I promised you. Spending more time doing validation to ensure the data that gets into that Lions database is as accurate as we can make it. And to ensure the accuracy of these things, we use combo boxes. Maybe in this case, there's only 4 plants, right? We could use radio buttons. And when you click on the plant that says Coloma, behind the scenes, the radio button code says 1. We have to code that. We have to figure it out. And you'll learn how to do that in Unit 4. It's a valuable skill, necessary skill. Good question. What else you got? All right, let's go back into the notes then. Talked about all this stuff, using aliases, using where. Ignore those. Unless, I don't think there's any questions in the assignment. Joni, you know, you've been through most. There isn't one in there that says use the where clause.
No, there's.
I don't think there is. So don't. Some said absolutely use join. There are other alternatives like subqueries. There are alternatives like subqueries that we haven't talked about yet. But stay away from where clauses to link tables together. There's a couple of examples in here. Just try to ignore those. So here's our classic ways. I do have a little errors in my notes yet that are probably not going to get corrected. These aliases are not used. There's no reason to put them in there. It's another advantage of the using clause is that you don't need as many aliases. They're not hard, but we don't need them. If you got it that far, I'm happy. Just leave it. Right here. It's on the recording. My genius technician, what did you have to do? Press the magic key?
Yeah.
Okay. I just didn't have time. She found it for me. I owe you. Thank you. So many irons in the fire. I'm surprised the fire's not going out. Okay. Today, let's talk about outer joins. This is where things get a little complicated. An outer join says, remember, Volker didn't show up in the trips list. Let's do the trips here. Select, that's plants. Here's trips. Okay, we added Volker. I'm just going to rerun this query real quick. This was just stuck in here from the last time we recorded. I didn't retype these. If you don't have them, don't worry about it. It's still a review. If I run that query, here's a bunch of people taking trips, and where did they go? And where's Volker go? He's not there, but I added him. I'm linking the trips table to the employees table. The only results you get is where there is a match in both. But what if I want all of my employees on this list, regardless of whether they've gone on a trip, because that'll tell me that Volker hasn't gone on any trips. Because right now, if you're not paying attention, you got thousands of employees, you don't get to see who hasn't gone on a trip this month. Because they're missing. Maybe you'll recognize that they're missing, but if you have hundreds, thousands of employees, you might not get to see that. What an outer join allows us to do is to say, I want every record in this table, regardless of whether there's a match in the other table. So it would give me the opportunity to bring Volker Gall into this list. It's called an outer join. An inner join, you only get where there's matching records. In an outer join, you pick one of the two tables in that relationship and you say, I don't care if the person, the employee, has been on a trip or not. I want them included. Right? So an outer join, I want them included, and then all the trips. We can go the other direction. Give me a list of trips regardless of whether there's a matching employee. That one to me makes no sense. Why would I have trips? Well, database errors that have anomalies, we'll use the big word. The anomalies have snuck into my database. There are trips whose employee no longer exists. Why did you delete an employee? They don't work here anymore. So? Then you say they don't work here anymore somewhere in the database. You don't delete them. Or you go into the trips table and say this trip was taken by employee number 99999 who represents a no longer works here employee. I don't want to lose my trip data. I don't think. Maybe after 10 years we delete them. But it's pretty rare that you do an outer join that says show me all the child records even if they don't have a parent. Because that shouldn't happen. What's more common is give me all the parents regardless of whether or not there's a child record. Give me a list of all the customers even if they haven't ordered from me yet. Those are examples of outer joins. Green, you've been doing outer joins in Lions?
Oh, yeah.
Oh, example?
When I'm getting the customer, I have to also get their name from the person's table.
When you get the, what was the first part? The first table?
When I get the camper,
Oh, camper. He's listening to me. He got customer on the brain. When he wants to get the camper,
I have to get their name
Yep.
from the person's table. So I have to do a join by the camper ID in the person.
but an outer join?
Do I do an outer join? No.
Linking, I should show you a couple of the queries they showed me yesterday. I looked at them and went, it's too complicated. I don't want to see it. They were join. There were 10, I think. 10 joins. Just to get one answer out of that thing. Now remember, I didn't mention it in the review that if you want to join table number 1 to table number 5 and there's 3 tables in between, you have to link them all. You can't just jump from 1 to 5 because 1 and 5 probably don't have any fields in common. It's what's in common are these tables in between. And so you have to link. And so the queries we were looking at that they were showing me with 10 tables tied together were only grabbing data from here and there. They had to bring all the other ones in order to make it work. And I think we had an example here someplace. I want the plant ID. No, that's not it. Let's make this go away. Getting sidetracked here. Sorry, I was talking about outer joins. Now Reen's got me distracted. Here we go. Plant ID. Nope, I need trips. Because I must have deleted it. But if I wanted to get the foreman's name of everybody who went on a trip to New York so I can go beat up on that foreman for whatever reason. Trips and plants are not connected. Not directly. There's an employee in between. So I have to link all 3 tables, which we did here, so that I can get the foreman's name and the destination and the trip date. So here's what that might look like. I think it's just foreman versus foreman name. Oh, there it is. There's the foreman out there. Never mind. Give me the destination, the trip date, the expenses, the plant name, and the foreman. But why does this say employees? I would probably flip these around if I were rewriting this, but it doesn't matter. But in order to get from plants to trips, I have to include the employees because they're in between. I don't have any fields here from the employees. I'm not even using them in the destination. Doesn't matter. You are using them in this join. You have to join those tables together. Does that make sense? Steve? Let me bring it back on the board here. That wasn't left-right shake, right? That doesn't make sense?
Right.
Probably because I'm making you visualize it. Here's my trips table. And here's my plants table. Those tables are not related. There's no plant ID in here that's saying, where did I go? They're only related because there's employees in between. And the employees are related to plants because who do I work for? Which plant do I work in? And the employees take trips. So if I want some fields from here and some fields from here, I have to link all three of them together so that I can get the results. Miguel?
So basically, the select you just put whatever you need on the select, but then you still need to declare all the links that you need to go through that.
Right. Well, again, this is where the ERD comes in handy because I just drew it. There's the ERD, minus the keys and the links, but that's the ERD. I can see Miguel saying, you want destination trip date from here, expenses, and you want plant name and foreman from here. That's what you want because that's what Boker's asking for, that's what your boss is asking for, whatever. It's your job in the SQL command to say, the only way I can get these and these is to complete the chain. Otherwise, when you try to run it, it'll go, these tables don't have anything in common, I can't join them. So keep that in mind when you're writing your queries. Now back to my friend the outer join here now. Right, we ran this query and said, and there's no Volker Gall here, which puts a lot of pressure on me to recognize that, hey, where's Volker? He didn't take any trips. Where's Reen? He didn't take any trips. Instead, what we often will say is give me a list of all, regardless of whether there's a child record that matches it. That's an outer join. Outer joins come in two flavors. So let's do this. Let's create another query just to get some practice here. And you know how to concatenate, so I'm just going to say last name, first name, destination, trip date. So looking up there, I'm doing employees and trips. Nothing magical, fancy needs to happen. They're already related. From TBL employees, inner join or just joins, up to you, TBL trips using the employee ID. That's what they have in common. And let me go back to my board here. Remember that a typical ERD will say that this has a trip ID. That's a key. Red is key here. This has an employee ID. This has a plant ID. And then your ERD also says that this employee has a plant ID link. And this trip has an employee ID link. Right? Nothing new there. So these, again, in the ERD can help me join. When I hit the using command, what do they have in common? Oh, there it is. Where the L is usually your clue. That's what I got to use to link these together. But you also have to double check to make sure they're named the same. You can only use the using clause, this one, the using clause, if the foreign key and the primary key are the same. And let's do an order by last name, first name. And just for practice, put another one on there, trip date descending. This is basically the same query I had up above. If I run this, Volker Gall is not going to show up. No Gall. Because this is an inner join. An outer join says, give me the records usually from the parent. regardless of whether there's a child. The parent here is employee going on trips. Should have put my ones and M's on there, but one employee takes many trips. Instead of an inner join, you use either left or right join. When you're joining these, the left and right, how do you know which one to use? Here's what I do if you're not sure. Put them back on the same line. Here's employees joined to trips. I want all of my employees, all of my parents. In this equation, the employees are on the left and the trips are on the right, right? Because here's my join. Simple as left and right. So instead of an inner join, we do a left join. What that says is give me all of the records in the left-hand table here, the one to the left of me, regardless of whether or not there's a matching child record. Well, when we do that, what do we get for destinations and trip dates? Nulls. There is no destination, there is no trip date, because I have not gone on a trip, but notice my name is now in the list. This is the purpose of an outer join. It's to show you all the records, typically from the parent, regardless of whether there's a child. When there is no child record, you get nulls for all the child fields. Doesn't cause an error. It gives you that child or that parent record regardless. So think customers that haven't placed orders, employees who don't, one employee, one parent, plants who don't have any employees yet. We just built it, nobody's been assigned there. That's kind of a weird example. Courses without students in them. That's a great example because right now we've got all the summer and spring courses out there getting, I think they're even available to you, getting ready for advising day in April. We got lots and lots of courses with no students. And so if I ran a typical query and said, give me a list of the rosters for each one of the courses, I'd get nothing right now because none of the courses have students in them. I couldn't even test it. So if I really wanted to test it, I'd have to say, give me an outer join, a left join to courses, courses connected to students, give me a left join. So that I get all the courses, regardless if anybody's enrolled in them yet. I'd have to do a left join on it. So that's a pretty good example. Good handle. There's also a right join. The only reason you would do a right join is if for some reason you put trips here and employees there, and then you join to the right. Because I want everything from the employees table. This would give me all the trips, regardless of whether or not there's a corresponding employee. There shouldn't be any of those because it says left, give me all the trips. But if you want all of the employees again, you can write it this way. This is the exact same query that I just ran. Should have made that new person. There we go. It's the same query. All I did is flip these two tables in order, and that's all it did. Then I had to say, no, I want my where. This right and left is you designating, there's my parent. It's on the right side of this equation. Think of join as the equal sign. It's on the right side or it's on the left side. Where's the parent? That's what you need to designate. Where's the parent? I think one of the examples, to give you another one that's in the assignments. Give me a list of the inventory in the Stevens Point bookstore, and give me a list of all the books, regardless of whether they're in inventory or not, so that I can see which books are missing. Because if I only ask for the Stevens Point inventory, it'll give me the books that we have on the shelf and how many of each. But it won't give me a list of the books that we're missing, that we're empty on, because there's no corresponding record to it. So left or right, I tend to go left just because my primary table, my parent table is typically listed first. That's just the way I write them. But what the left or right join, those are both outer joins. The full category here is outer join. They're inners and outers, that's it. Left and right are two subcategories of outer join. You never type the word outer. There's no such word. There's no such keyword. It's just a descriptive name for left and right joins. They're outer joins. Why outer? I don't know.
So basically, if you only had like the name there and no other information, it would still like use an outer just to show that it's still there. Then and then all the other fields.
If I just had the name, as in take these out,
I mean, like for like both of them all, like you don't have any information in the others, and the outer just displays.
the outer displays nulls for the child record that doesn't exist, right?
Otherwise, if you use inner, then it won't be there.
It's not there at all. That's right. If you use an inner join, it just doesn't show up. And the bad news of it doesn't show up is I don't know that it's supposed to be there. Okay? We have Gone with the Wind. We're trying to sell it. There's none in the Stevens Point bookstore. Uh-oh. It never even shows up if you do an inner join. And so it's harder sometimes. The answer is misleading because the stuff that's missing is hard to tell. Other questions? Now let's see what I forgot in my notes. First of all, over here it says list the dates that each employee traveled. That's what we just did. Notice that there's no Volkergall. Then we use an outer join. That's what we just did. And Volkergall's trip date and other information is null. That's good. And then here comes the tricky part. Oh, I'm sorry. One more type of join that I have never used is a full join. The biggest problem with full joins is they usually have so many records that most queries won't let you do it because if you have a lot of data, you get every single record in the parent and every single table in the child, whether there's a match or not. I've never used one. But it gives you, it's kind of a left-right join, if you will. Give me everything from every table, regardless of whether it has a match in the other side. I've never used one. Left and right joins I've used. Primary reason I've never used one is I don't have databases where there's child records without parents, so full doesn't gain me anything. But you may have some old archival databases that you're supposed to analyze. Full join can give you a nice analysis and say, here's all your records and their matches. Got some orphans out there that we had to deal with. One kicker, though, is let's say I want a list of all the Chicago trips. Is this my query? No, I guess it is. I want a list of all the Chicago trips, but I want all the employees listed. Give me a list of the employees who went to Chicago. And if they haven't been, then make that part of the list. Here's your first thought process. Where clause has to come before the order by clause. No semicolon. Okay, so this says, give me a list of all the names and people who went to Chicago, but because it's a right join, it should give me a list of all the employees. That table to the right, give me all of them. It should give me a list of all the employees. There's the Chicago trips. But there has to be somebody like Gall, for instance, who's missing, who hasn't been to Chicago. And there's others that are missing. I can see that. How come they're not on the list? I said, give me a right join. This is where things get a little complicated. I think most of you got your head around the left-right join, the outer join thing. But where things get complicated is if you also have a criteria, a filter, where the trip destination is Chicago. and you're trying to do an outer join. If you try to do both using this technique, it obviously doesn't work. Why is it not working? Because the where clause happens after the join. The where processing happens after the join. So behind the scenes, SQL is making this lovely list of all the people who went to Chicago, and here's their names, and everybody's name, because we set a right list and a right join. I got everybody, including people who've never been to Chicago. And then there's a where clause that says only include the trips to Chicago. And so all those null records get filtered out, even though you said right join. Kind of counteracts each other. How do we fix it? So that I say, give me a list of all employees who've been to Chicago, and if they haven't been, list those in all employees, period, and which ones have been to Chicago. How do we fix it? First thing is we can't use a using. We have to go back to a on, and then I'm probably going to want the T table alias and the employee table alias. And if you were making your own and going to try to save this, maybe you're better off copying that entire. Let me undo here. Undo. This we discovered doesn't work, so I'm going to take that out. There's the query that works, but I only want Chicago. So I'm going to copy this query so that you can see both in yours and in the recording. All right, and then I said where, and that wasn't right. So I said we need to change this part. Trips, given an alias, T. Employees, given an alias, E. And then I'm going to join them using the on clause. This is another reason you still have to understand that on clause. Using doesn't cover everything. On T.employee ID equals the E employee ID. That's just the alternate way of joining them. Instead of using, we're using on. So I'm going to run that and see we get the same list. Right now there are 25 rows. And now I get 301 rows. What? What? 301 rows? Oh, no, this is fine. That's every single trip plus me, though, who didn't go on a trip. I'm missing my where clause, right? So I'm going to put the where clause in. This should solve the problem. No, it doesn't. Where the destination equals Chicago. Now I should get my 25 rows. There's my 25 rows. Hard for you to see, but I got all 25 again. It's still not right. Where's Volker Gall? Where's these other people that never went to Chicago? We said right outer join. Here's the way I explain it in my notes, and here's the only way I can explain it to you. What you have to do to get this destination to stick and not overwrite this right join is to use and instead of where. There's no where clause. This and is really part of the join. It says join them together wherever the employee IDs match and the destination is Chicago. So it's part of the join process now. I'm moving that over just so that you can see that it's really the second part of this. Join them on, we can join them using multiple fields if we need to. I don't do it very often. But if you have an outer join, this is one of those weird situations. You have an outer join, left or right, and you have a where clause. You have both. The where clause overrides the join, the outer join. The solution is to use the word and instead. So this says join them together wherever the employee IDs match and the destination is Chicago. It's all part of the join. And notice all the people who did not go to Chicago. Okay. Annette, Tina been there twice. That's fine. But Andrea and Arnold and Louise have never been there, at least not this month in this set of data that we have. So that's a gotcha that I try to document in my notes. Here in the red, it says use and, not where. Remember the little hairs in the back of your neck in programming logic beginning, the little things that happen like when you're doing math, you're doing dividing, little hairs in the back of your neck go up, warning, warning. Could be losing decimal places here if everything's an integer. There were other little hair in the back of your neck things that you needed to worry about. This is the hair in the back of your neck thing in SQL. An outer join with a filter. Everything else pretty straightforward, but an outer join with a filter is going to cause trouble if you're not careful. It's a quick solution. You don't use where for the filter, you use and as part of the join. When you do an outer join, I want all the books, regardless of whether they're in the inventory. When you do an outer join, you should expect to get some null records. If you're not seeing them, you didn't do it right. In the homework. Real world, there may not be any books that are missing from inventory. There may not be any. But here, I guarantee you, there'll be some that are missing. Just like here with my trips example, there are people who have not been to Chicago. If I don't see any nulls, something's wrong with my query. When you do that kind of query, that raise the hair in the back of your neck query, it's an outer join with a criteria. You must use an on to link the tables and to designate the criteria. Notice there's no where clause here. We're filtering as we join at the same time. We join the tables together and we filter because we are only joining whenever we're going to Chicago. Very dangerous potential gotcha. Here's some other examples. Give me the total order of all customers, regardless of whether they've ordered. How much have they spent here? Well, somebody's never ordered, they don't show up on the list. And maybe those are the people that I want to send a flyer to everybody who's ordered less than $1,000 worth of stuff. Well, if you haven't ordered, you don't get a flyer because you don't show up on the list, unless we do a left join. We can do group by. So here's an example of a group by. I want the total for every customer, regardless of whether they've ordered. Give me the total for all customers who have ordered after April 1st of 2014. This is a criteria. It's a filter. What? My notes say you can use using. That might be an error. I might have to fix that one because it's flat out wrong. It's wrong. Notice the red squiggles under and going, and what? Wait, what? Well, there's no and here. There's no joins. There's no where. How can there be an and? And it says I can't do that. So that's a mistake. I will fix that one. This needs to be converted to an on. I can do a right join. That's not a problem. But I have to say on O customer ID equals C customer ID to join them. Then the and clause works. One other thing that Joni helped me discover, you all owe her something. If the snack cart comes, you all collect and just dump them on Joni's desk because she's fought with this assignment already, right? And found a few flaws in it when I rebuilt it for the new databases. So you found these flaws. Occasionally, when you do outer joins, the order of the join sometimes is more important. What if I want to join all of my tables? Let's see, I'm going to finish this in about hopefully 10 minutes here. I want to join all my tables. I want to know the foreman's name and the employee's name and the destination and the trip date. But I want all employees. Whoa. Whether or not they've been on a trip. Now I got 3 tables that I'm joining together here. I'm making this one up as I go, so bear with me. I could screw this up because it could get complicated. The point here is sometimes you need to link these in the right way. What I recommend you do when you have an outer join mixed with an inner join, because my foreman and employees, every employee has a foreman, every foreman has employees, that you link those together first. Do your inner joins first, is my recommendation. Let's see how this works. So I want to say from TBL plants, because if I'm looking at my diagram up there, plants links to employees, links to trips. So I'm just working my way right to left for those of you who can see it on the screen. From TBL plants, inner join TBL employees, because I don't have any plants without employees. Using the plant ID. So looking at that diagram, what they have in common is plant ID. This is an inner join, so I don't have to use an on. I could. I'm going to use the using clause. And then I want to join that. I'm just going to say join for right now with TBL trips. T. That order is probably important because this is an inner join, that's an outer join, and now I can say using the employee ID. That works okay. But now I want to get into that, whether they've been on a trip or not. Volker Gall should show up on this list. I hope. So let's test that first, and then we'll add the Chicago component. Uh-oh. Oh, I don't have an order by.
Isn't inner join and join the same thing?
Yes, I'm sorry. So this is showing, this Volker Gall is not going to show up here. Let me put my order by in here. Order by last name, first name. I'm not going to worry about the trip date because I just want to see whether Volker's there or not. Volker's not going to be here because this is the same as an inner join. Thank you for reminding me about that. And there's all the names, and I get down to the F's, and why aren't they sorted by last name? Those are concatenated. I didn't ask for concatenation. Oh, that's a foreman's name. I'm sorry. Here's the first name, last name. So we're looking for Gall here. Not there. I need all my employees. Okay. So this becomes a what kind of join? I'm joining my employees to trips. I want to see all the employees. Employees is on the left if I were to write this out as one big sentence. So I want to do a left join. Does Volker come back? Again, we have to look under last name here. Yep, there he is. Notice I do have a supervisor. Never been on a trip is what this is telling me. But now I want to go to only Chicago. Oh boy. So again, programming logic. I've been teaching you build programs in pieces. Build SQL commands in pieces. Give me a list of everybody. That's good. Give me a list of everybody who's been on a trip. That's good, but I want everybody, whether they've been on a trip or not. Modify it. Build it in pieces. Now I want to add my, you had to go to Chicago. Well, we discovered that using a left join and a where don't work very well because all the nulls disappear again. So now I'm going to change this once again and use on my employee ID is equal to my trip employee ID, and the destination is Chicago. $25, 56 rows. That's interesting. Why is it 56 rows? All I did was added the foreman's name to this. I guess it was 56 before. I don't see any duplicates. I'm just kind of going through the names to see if anybody's name shows up more than twice when it's not a trip. I don't see it, so I think that must be the right answer. My first question is, how many employees do I have? 51, because I added myself. So I should get at least 50. But some people are going on multiple trips, so some of those are adding some extra rows, so that may be what's going on. That looks right. So in this case, the order is important. I think if I were to move my employees first instead of plants and try to join in the wrong, if it doesn't work, try rearranging the way you order the joins. Occasionally, there's a couple of extra credits. Here's your tip. Occasionally, you need parentheses. That gets even more complicated. Because I have to think really, I still have to think very hard about where do my parentheses go. This join ends up with kind of think of it as a temporary table. Okay. Plants to employees. Okay, you got them. Here's all your plants and employees. Got them all joined together. That is a done deal. So I can put parentheses around it and say that big old group do a left join to trips. But notice where the parentheses are. Sometimes the location of the parentheses can be very complicated. If you're doing the extra credit and you can't quite figure out the parentheses, that's what's going to take. Let me know and I can try to help you. But what if I want plants joined to this? Can I do that? Yes. If you put parentheses in and you don't get errors, you did it right. But notice I got an error. I got an error because this using plant ID has one table employees that's inside the parentheses and plants that's outside the parentheses is going, I don't see that. This is extra tricky. The using can't be inside the parentheses, so I have to remove it. And now it says inner join plants with the employees joined to trips, but I have not designated how to join plants to these. It goes after the parentheses. This is a table. This is a big table with its parentheses. And the using goes after, and this one blew my mind when I first saw it. Because it says, here's one table, plants, joined to this big, huge parenthesis thing. How do I join plants to the big, huge, ugly parenthesis thing? Here's how you do it. The using has to come after the two tables, if you will. Took me a while to find that one. It can get tricky. It's only a problem when these left-right joins come into the picture. If you're doing an inner join, it's pretty straightforward. Doesn't really matter what order you join them in, typically. But if you start doing inner, outer joins mixed with and clauses and things, that can get a little complicated. Ask me for help. let's stop there. Gives you about a half hour to work single table queries. If you're starting multi-table queries, whatever you need help with, or your brain's tired, take the rest of the day off. It's up to you. Well, let's stop on that outer join. When we come back next time, we'll start talking about self-joins, tables joined to themselves. I don't have a very good example of this here. That's employees, supervisors. They have some other reasons to use this. We'll talk about them. And then subqueries, which are select commands embedded inside of other select commands. We'll save that for after break when your brains are really well rested. Remember, I have one rule for breaks. You come back. Okay? Don't do anything really dangerous like go surfing in the reefs and all that kind of stuff. If you break legs, that's okay. Don't break fingers because you need to type. Enjoy your break.